Good morning, everyone. This is Sara Nada. We are continuing our course Game Theory. Starting from today, the course will be audio recorded. So let's see what we have for today's lecture. I make the correction, so today's lecture that should be on March 17 is lecture number 12. So this is correct. Let's see what we have for today's lecture. Okay. Remember the last lecture that we had in class at our faculty, we were studying the mixed strategies. Besides, we solved a couple of applications on mixed strategies. So now that you studied mixed strategies and know how to solve for them, we should revisit the dominated actions that we studied in the beginning, the first part of this course. Kindly note now that you should consider mixed strategies also in the iterative elimination of strictly dominated actions. Okay, so because you know about this concept now, if you are solving for the iterative elimination of strictly dominated actions, you should consider also the mixed strategies. How can a mixed strategy be strictly dominated or strictly dominating other action? So, a mixed strategy PI star strictly dominates an action profile AI if we have the expected utility of PI star and A minus I is greater than the utility from AI and A minus I for all A minus I. You should be familiar with this notation because at the beginning of our course, in the first part of our course, we explained all these notations, so you should know what does this mean. Again, back to the point, a mixed strategy strictly dominates an action profile if it gives you a higher utility as expected. So, in the iterative elimination of mixed strategies, you should eliminate every strictly dominated action, including the actions dominated by mixed strategies. Okay, this is a note before we start a new topic, which is dynamic games. Remember what we were doing up to here? We were studying sequential games. And you asked me several times about what happens if one player chooses an action first and then the other chooses in a next stage. This is the topic of dynamic games. Dynamic games can also be called sequential games. So it is the same to say dynamic or sequential. These games are games where one decision maker or one player moves first. Then the second player or the second decision maker observes the action taken by the first decision maker and decides on his action afterwards. Okay, so this is what you were waiting to see about the games that we were studying. So instead of having simultaneous games, when we are playing a dynamic game, when there is a dynamic game that we are studying, one player will move first and then the second will observe the action chosen by the first player, the player who moves first, and then chooses his action at a second stage. This is totally different from simultaneous games that we have explained thoroughly in the first part of this course. Dynamic games can be represented by the extensive form of the game or what we call simply the tree. So, in order to represent a dynamic game, we call its representation extensive form or a tree. What is this form? It is just a drawing like a tree. So, let's draw this and see if you can clearly get the point. First of all, we will assume for simplicity that we have two players. If we have two players, this means that one player will take his action at the first stage and then the second player will take his action at a second stage. Assume that our players are called A and B. So if we want to start, we will draw a node . This node here is representing the starting of the game. So I said that we will assume that we have two players A and B. So, and for simplicity, we will say that player A will start the game. So if player A will start the game, then at the initial node, at the starting node of the game, I will put the letter A. Why? To refer to the player that is taking his action at this stage. Another simplifying assumption, I will assume that each player has two strategies to choose from. Okay? So, what does this mean? We have the starting node. Then we should draw other lines. Let's choose the green. So we should draw other lines. How many lines? Depending on the actions that are available for the player. So as I said that there are two actions that are available for player A to choose from. That's why you can see that there are two mini straight lines that are going out from the starting node. Each side, one is going out towards the left side and the other is going out towards, so this one is the one that is going out towards the left side, and this one is the one that is going out towards the right side. Each of these two lines are representing one of the actions. Just because I'm explaining a very general example, so I'm not writing the actions, but you are expected to write here the action that is available, the actions on each line. You should write the actions that are available for player A. Okay? So this represents the first stage. Okay? We said that at the first stage, player A will choose an action. So player A will start from the starting node. We will draw the two actions that are available for him. Once player A chooses his action, what happens? The other player, player B, will observe the action chosen by player A, and he will also choose an action from the actions available to him. So this is the second stage. At the end of the lines, we will draw another nodes at each end to represent the second stage. Okay, so each node is representing a stage. Okay, and at these nodes we should indicate which player will take his action. So I will write here B, and I will write here B. Okay, this means that at this node, at this stage, player B will choose his action after observing the action chosen by player A. Okay, because of our simplifying assumption, I assume that each player in this example, I assumed that each player has two actions to choose from. So in this case, I should draw two lines going out from each black node. Why? Because there are two actions that are available for player B. Okay? For simplicity, I will assume that the game will stop here. If the game will stop here, then we are expecting to have at the end of each terminal position the payoffs that are available, not that are available, the payoffs that each player will get. Okay, so these brackets are just representing the payoffs. So for example, we can write here, let's say 0, 0. We can write here 1, 0. We can write here 0, 0. And we can write here 1, 1. This representation or this drawing that is in front of you is what we call the extensive form of the game, or you can call it the tree because it's like a tree. It is representing the dynamic game that we assume to have. So in the previous tree that we drew, there are two decision makers, A and B. Remember, A decides which action to choose first, then afterwards decision maker B decides upon his action. Why is that? Because we assume this. Player B observes A's chosen action before he decides upon his action. Remember that in the previous tree we had each player has two actions to choose from, and the payoffs are given at the terminal positions. So this was the brackets that we drew at the end of the tree. Okay. Note, the extensive form representation can represent games with more than two players. All the assumptions that I made about the example were simplifying assumptions to make you understand what is the extensive form or what we mean by a tree, but it can be more complex than this. And in the next lecture we are going to take different examples to let you understand. I'm going to explain and draw for you different examples to let you clearly understand that it's not necessarily to be like this. It's not necessarily to have two players, and it is not necessarily to have all the assumptions that we made. But for sure remains one thing, that one player takes an action first, and then the second player observes the action chosen by the first player and takes his action afterwards. An important assumption in the extensive form games is the assumption of perfect information. What does it mean to have perfect information? Perfect information means that each player knows about the history of the game and all the actions that has taken place previously. Remember, when we were drawing our example, our simple example, we said what we have two players. If player A will move first, then player B will observe the action chosen by player A, then he will choose his action afterwards. So this is the perfect information. Remember this assumption about the perfect information. Now let's explain what are the key features of dynamic games and state them. A dynamic game with complete and perfect information has three key features. The first key feature is that moves occur in a sequence. As we said in our example, in our simple example, we had two players. One player moves at the first stage, and then the second player waits until the first player takes his action and he observes the action chosen. Then at a second stage, the second player moves. So moves occur in a sequence. The second key feature is that all previous moves are observed before the next move is chosen. And the third one is that players' payoffs are known to all players. The payoffs from each feasible combination of moves are common knowledge, so they are known to all players. Briefly, we have three main key features for dynamic games with complete and perfect information. Moves are sequential. We have previous moves are observed before anyone takes his action or anyone takes the next move. Then the third one is that the payoffs are known to all players. How to solve these dynamic games that we have explained in today's lecture? Well, next lecture we should discuss this point, like how to solve or what will be the solution of such a dynamic game, what will be the actions chosen by each player, and how they will do that. So next lecture we are going to use the backward induction method. In this course we will just use the backward induction method in order to solve sequential games. And next lecture also, before using the backward induction, as I mentioned, I will draw and explain different examples in order to let you show the different extensive forms or different trees, different types of dynamic games. So we will keep this for next lecture. Now it's questions time. Do you have any questions? Unfortunately, I will not be able to take your questions live in class, but still through the audio recorded, you can hear my voice, you can hear my explanation, and you can repeat it as many times as you can. If you have any questions or comments, you can always send me an email. My email is written here. It's this one, sara.nata@feps.edu.eg. So this is my email. You can write to me. I reply as soon as I read your email. Don't worry. So that's it for today, and I will be happy to receive comments or questions from you. Thank you, and see you next lecture to continue our topic of dynamic games.